Okay, GCSE mock exam year 11 question 8. This is a really big ticket question, a question that we really need to make sure we've revised the required practicals. So, start off with a quite simple one. Now we've got a clue here where it tells us that there is a solid sulfur made in this reaction. So we've got the equation for the reaction. Sodium thiosulphate plus hydrochloric acid goes to sodium chloride plus sulfur plus water as a liquid plus sulfur as a solid. And there's our clue. But to be quite honest, this is one you should just remember. So, solid sulfur is produced as a precipitate. And that's it. We get 2 marks for saying that solid sulfur is produced. So, question 8.2. This is the big question. 6-mark question. Now, it's an investigation. We always start investigations by stating our variables. So, we're going to start by stating the independent variable. Plan an investigation to show how the concentration of sodium thiosulphate solution. So, that's our independent variable. Independent variable is concentration of sodium thiosulphate. Now we've got dependent variable. Try not to use acronyms for independent and dependent like IV, DV. Really should write independent, dependent. The independent variable, so plan investigation, show how the concentration of sodium thiosulphate solution affects, that's our keyword, affects the rate of reaction. So our dependent variable is rate of reaction. And we'll talk about the specifics of that in a minute. And then our control variables are variables that we keep constant. Well, there are several of these that we've got to use. So we're changing the concentration of sodium thiosulphate, but we're keeping the volume of sodium thiosulphate the same. So volume of sodium thiosulphate. We're also keeping the dilute hydrochloric acid the same. So the concentration and volume of HCl is staying the same. So let's go through our steps. So step 1, we've got to state what we're using a measuring cylinder. Add, and in this amount isn't really essential. You can get away with saying different amounts. Add 25 centimeters cubed of dilute HCl to a conical flask. You could do this experiment in a beaker, but the conical flask is better because you swirl it more. 2. Now this is how we're going to measure the rate of reaction. Again, it's part of the core practical. The way we measure the rate of reaction is we have a subjective view of whether or not a cross has disappeared. So we place a black cross under the conical flask. So now we're ready to start the reaction. So we place a black cross under the conical flask. And now, again, using a measuring cylinder, we're going to add 25 centimeters cubed of, and we're going to pick a volume here, a concentration here. Now, it doesn't really matter. I'm going to state that it's 1 molar. There are different ways of saying this. I'm just going to say add 25 centimeters cubed of 1 molar sodium thiosulphate, because I'm going to assume that we're using 1 molar hydrochloric acid. So add 25 centimeters cubed of 1 molar sodium thiosulphate using a measuring cylinder to the acid. Step 4, start a stopwatch. Again, we're stating the piece of equipment. We don't just say time the experiment, we say what piece of equipment we're using. Step 5, when the cross is no longer visible, I'm going to say particularly from above, stop the stopwatch. So now we have calculated the amount of time it's taken for the reaction to occur. And now we need to do the experiment again. Now technically we're not repeating the experiment here, we are doing an experiment with a different value of the independent variable. We can't call that repeating. So we do the experiment again with 0.75, 0.2, 0.5, 0.25, and just to pick another one randomly, 0.1 molar sodium thiosulphate. Now you could just say, do the experiment again with 4 other concentrations of sodium thiosulphate. That would also be acceptable. Now we can also say, just to kind of hedge our bets, 7, repeat the experiment 3 times. It's always a good thing to write, and calculate the mean time taken. Now finally, we we could put a safety comment in here. It's not essential because it didn't say to conduct a safe experiment, okay, but we're going to put it in anyway because it's always a good thing to write. Where goggles as HCl is harmful. Even if it doesn't ask for it, I would still always put it in. It wasn't required by this mark scheme, but that's very good. Okay. Now, last of all, you could talk about converting the rate. You could talk about converting the time taken into a rate, which would be really the top kind of mark. And probably you wouldn't even need to say this to get 6 marks, but you can convert time taken into a rate of reaction by doing 1 divided by time taken equals rate. And that gives you a number that you can plot on a graph, and that graph should then appear, when you do a graph of concentration versus rate, would appear linearly, but or appear directly proportionally. Again, it's not really essential 8, but I think it's a good thing to say how you would then calculate the rate. But the important things here, to go back, is using the black cross, using a fixed concentration of sodium, so using a fixed concentration of hydrochloric acid and volume, using a fixed volume of sodium thiosulphate, but changing the concentration, using a measuring cylinder to measure the volumes, using the stopwatch to measure the time, and doing the experiment with 5 different concentrations. And finally, repeating the experiment and calculating the mean time taken. So those are all really essential points to get to the 6-mark threshold. If you have a method that's not going to give valid results, but has got some of the steps, you'd get 3 to 4. But if you've got something that only has a couple of valid points but isn't really a valid method at all, you might qualify for, I should say HCl, for 1 to 2 marks.